And thanks for joining us today for our Air France KLM by AfricArena challenge. We are going to have three amazing businesses today that will be pitching their solution to answer the Air France KLM challenge. For the ones that are not familiar with the AfricArena brand, Africa Accelerator based in Cape Town, South Africa. And what we do is we do the bridge between the corporates, the investors, and the entrepreneurs. And we do that by running mainly corporate open innovation challenges, even though we also have a bunch of side activities on the side. You can find all about this on our website at africarena.com, where you'll also be able to find our latest 2020 report about the state of tech innovation in Africa. For today, as I mentioned, this event, this challenge is in partnership with Air France KLM. Without them, this event and challenge would not be possible. Air France KLM has been working with AfricArena since the very beginning, so since 2017, and they have been a partner for all of our events and all of our summits. Today, we have the chance to have Alexandra Tronel with us, who is going to say a few words about the group and give us a bit more context regarding the challenge. Alexandra, over to you.
Yes. Good afternoon, everyone. So Air France KLM is a Franco-Dutch airline area. We usually transport something like 85 million passengers a year to more than 1,000 destinations in 170 countries. Africa is a very important area for the group because we have something like 60 destinations and approximately 120 flights a day. So that's, of course, the figures are based on 2019 because 2020 won't be the same. We all know that. Air France is mainly involved in the western part of Africa, while KLM is more involved in eastern part, and South Africa is for the two airlines. So our challenge today is about the water filling. Currently, and for many years, the group used to apply a precaution principle in Africa. So we mainly fill in water in Charles de Gaulle or Amsterdam Schiphol for the round trip. Now, for environmental reasons, economic reasons as well, we would like to reduce the quantity of water from our main bases. So that means that we want to fill in water from African cities. But of course, quality of water is very important. We don't want to take any risk for our passengers and our crew members. Mm-hmm. Thank you very much.
Thank you very much, Alexandra. Thanks for the definition and the context of this challenge. Let's move on into directly the core of our event. So the program of today, we are going to have three entrepreneurs pitching their solutions. We are going to have James Steers from iDropWater, who is going to be pitching first. iDropWater being a South African water tech company that develops advanced grocery store water refill systems. Then we will have Mobi-Water, who would be pitching its solution after it. Mobi-Water, a Kenyan-based water tech startup that develops remote real-time water management. We will then have Morandini Fomo, who will be pitching Cushion Water, a Johannesburg-based water tech startup that aims to make clean and safe water available to communities. The rule of this pitch is quite straightforward. We have 14 minutes per entrepreneur, per startup, and we have a 7-minute and Vanessa, who is also in this call. Without further ado, James Steer, hello.
Hello, thank you.
Can you hear me? Can you hear me well?
I can hear you fine. Can you hear me?
Perfect. So thank you for joining us today. James Steer, co-founder of iDropWater. So you will be the one pitching first. Would you please, I'm going to stop sharing my screen and I will let you share your screen.
Okay.
And you'll be able to present the deck. Again, 7-minute pitch. I will be running a timer that I'm setting up right now. And yeah, so you have 7 minutes to pitch your solution, and then Alexandra and Vanessa will follow with the Q&A. James, it is up to you. Whenever you start, I start the timer.
Okay, great. Thank you very much. Yeah, I'm James Steer. I'm a co-founder of iDrop Water. We established iDrop in 2015. I did with a classmate of mine from the Said Business School MBA program at Oxford University. My background is originally in management consulting. My co-founders is in large-scale, M&A program management around Europe. This is important because we founded iDrop really to take a commercial view on solving this great big global challenge. We think this is missing in the drinking water industry. Bottled water is a false solution, and a lot of nonprofit models we think face limitations in scale and sustainability. So our real core objective with iDrop was to look for commercial solutions that enable businesses to tackle this global challenge. Now, how we did this is we developed a number of small-scale applications of decentralized purification technology into systems and then integrated them with a bespoke Internet of Things monitoring and control platform that we've been developing for the last 5 years. So I for Internet and Drop for water purifications. Our platform is relatively sophisticated and mature now. We've trialed it in multiple countries across Africa. It gives us all sorts of functionality. And our core product, our flagship product right now is called the Water Pod. We install these in grocery stores. It's essentially miniaturizing the water kiosk model that enables shoppers to refill drinking water by the liter and pay by the liter for the water that they need. Now, what we realized with this is that we in fact haven't so much developed a product as we've developed a platform. And that's important because what it's helped us do is work with other clients, third-party clients, to develop solutions for multiple industries, not just grocery stores. This is an example. The client brief was that we needed to solve a challenge for events, large-scale events, outdoor, as well as TV production sites. Some of these sites didn't have source water, so we would need to transport it. It needs to be mobile, high quality of purification, in some instances sparkling and chilled water. So we developed this from design phase all the way through to commercial application. And this slide shows you a couple of the activations. It's been hugely successful. It's been used at outdoor marathons on the side of Table Mountain, all the way through to construction sites, high-profile golfing events, and music festivals all over Southern Africa. An example of how this has worked is at a big music festival. So tens of thousands of people attended this outdoor festival outside Cape Town over 3 days. We were the sole on-site water purification and service client or supplier to this. And over the 3 days, we served over 18,000 liters of purified water using farm water as an input. So we had some experience in solving this kind of challenge. We've won a number of awards in this territory, not only for the innovation in our solutions, but actually also in our business model. Our commercials are quite innovative and they've been recognized. To this challenge, we've looked at the brief and understood it really in 3 ways. First of all, obviously there is a requirement for safe onboard water for people who are flying, but not everyone is flying. And so there also needs to be a solution for ground staff. The third category here, and one that we think is actually one of the most important, is that airlines are very complicated operating environments. And so integrating whatever system is being developed with operating logistics is critical. And so we look at this slightly differently in iDrop. We think that this is largely a logistics challenge with a drinking water component and not the other way around, because the number one objective has to be a commercial one, which is the on-time departure with 500 liters of safe drinking water every single time. Now, the challenge here is that if you take a value chain view of this, there are 2 competing pressures. One is that water purification typically likes to be slow and fixed, but on-site operations at airports are fast. They change, there's weather, there's delays. These are dynamic processes. And so inevitably, if you take a standard value chain approach, you're going to get these single points of failure. So in iDrop, we think this needs to be looked at a little differently. We think a more sophisticated view of the value chain would look a bit more like this, with multiple points of redundancy management throughout. So first of all, source water. At airports around Africa, you're going to get water outages. So you need to create an on-site reservoir to store available water. Secondly, water in Accra is very different from water in Johannesburg. So you need to match the primary purification with whatever the source water is at that site. And again, create redundancy points. So multiple secondary reservoir tanks. This means that if one tank is being fixed or maintained, you have secondary tanks available. Third, whenever you put water in tanks, things grow. There's nothing you can do about that. And so we think the interesting opportunity here is to integrate water polishing or secondary treatment in a vehicle that would transport, transfer, and onboard water from the purification site to the airline. And this is how it would look. Essentially, the only, the particularly interesting part of this is that we think it should be in a micro or a smaller compact water trailer. This is a familiar way of moving things around on airport sites. There are towing vehicles available. So it uses what is already on site and is relatively easy to integrate. This value chain would also allow for multiple points of monitoring from the input water all the way through to the onboarding process. Now, what's important out of this approach too is that it doesn't require huge complex product development because many of these systems already exist. It's a matter of using local expertise to deal with some of the more straightforward solutions like backup reservoirs and potentially even primary water purification. There are experts in all African cities that know how to primarily treat input water the most efficiently and the most effectively. Where there is scope, obviously, for integration is with IoT monitoring of water quality and service, as well as on essentially a compact water trailer, which would be a combination of various things into a mobile system that can be towed around the airport site by a towing vehicle, again, with integrated IoT monitoring. We summarize this all then into the following, that in order for a system to work, it has to work in the environment that it's designed for. And so the key principles we would apply, to summarize, really first understand the logistics process chain in a more sophisticated way, to understand the constraints and to mitigate with planned redundancy backups on all the potential points of failure through the site. So all the way from primary water supply to actual onboarding, we want to make sure that that core objective is always maintained of on-time departure with 500 liters of safe drinking water. And to do this, we need to look at what's already available and what is familiar to the operators on these sites. The number one objective, and we keep this as top of mind as we can with iDrop all the time, keep it simple. Thank you very much. Any questions?
Thank you very much, James. Perfectly on time, a bit before 7 minutes. Thanks. I'm now going to open the floor for Alexandra. Do you have a question first or Vanessa?
As you want.
Alexandra, go ahead, and
Okay.
then I will ask Vanessa. Let me just reset the timer. Okay, we are going for 7 minutes.
Okay, so for me, it's not clear how the water is purified. Can you explain that, please?
Sure. At primary purification, it's going to, I would recommend, depend on the source water. So we know, for instance, that source water in a city like Accra in Ghana has a very high level of dissolved minerals, dissolved salts. And so for that installation, you would need to integrate a reverse osmosis treatment. Now, the reason we separate primary from secondary purification is that reverse osmosis is a very slow process. And so you want to spend enough time filling primary reservoir tanks or secondary reservoir tanks with RO purified water. The secondary purification really is dealing with the challenge that once you have normalized levels of dissolved mineral salts in a water, things grow in tanks. And so you need a secondary level of purification that will deal with your microbiological contaminants. Typically, this can be done at a much higher capacity, which means it can be integrated with the transfer, transport, and onboarding model. For that, I would ideally use a combination of carbon filter plus a excuse me, high capacity ultraviolet sterilizer. But in terms of the purification options, there are many. There are a lot of good purification systems out there that deliver efficiency, and it can be tailored to these two different types of throughput capacity and challenge water purification type.
Okay.
Thanks, James. Vanessa, a question?
Yes, one of my questions is joins Alexandra's question. There is no filter to purify the water?
No, there absolutely is. There would be multiple filters throughout. So at the primary purification system, we would probably there, I'm not sure if I'm still sharing a screen, but we would look at something along the lines of a relatively high capacity reverse osmosis system which you would need to integrate with sediment filtration and post-filtration mineralization, as well as ultraviolet filtration. I think that what the point I was trying to emphasize here is that is not particularly difficult to design and install. We have across Africa very challenging water qualities, and so there are a lot of companies, ourselves included, that know how to build those systems. So the challenge is not so much purifying the water, it's more, once you have purified it, how do you store it safely? How do you purify it at a capacity that doesn't interfere with the value chain? And then how do you move it from your primary site to the onboarding process on the airplane without moving it into tanks that are unsafe? So the secondary purification would happen immediately prior to onboarding. And that would involve ultraviolet sterilization, as well as, filters, be they carbon filters, be they nano filters, that can be tailored to work best. But no, there are multiple points of purification here, but our key point is that it needs to be integrated with a holistic view of the value chain to manage these various faults that are going to happen, such as water outages, such as extreme temperatures, extreme humidity on site. And so that's why we take this slightly more nuanced view of the value chain with multiple points of purification and capacity.
Thanks, James. We have a bit more than 3 minutes left. Vanessa, would you like some clarification on this point, or?
No, but if we have time, just another question. When will water be analyzed, and which parameters will be checked?
So microbiological testing in real time is not possible through this. We can infer the quality of the water through how it interacts with certain types of filter, and that can be monitored in real time consistently. But dissolved salts, minerals, those can be analyzed using the various sensors that we have in our IoT system. So those are values that are sent through to us consistently. As long as there is a cell phone signal and our technology is communicating, those come through in real time. The fact is, though, the testing for microbiological contaminants at various points it requires preparing cultures and growing these in laboratories. So that testing process would have to be integrated anyway, just as good practice. But it's more analyzing TDS levels, various other sensor data through the system, and that can be done at multiple points. The most important one being immediately prior to onboarding into the plane to make sure that water quality is as it should be.
Thanks, James. We have a bit less than 2 minutes left. Alexandra would like to jump in with another question.
Yes, I have a question regarding the maintenance. Is it a system easy to maintain?
Maintain. I mean, that's primarily why we would look at using existing components rather than trying to invent something completely from scratch here. Is that there are in any major African city, there are going to be companies that deal with these standard components, and so servicing is essential. What's really good about our IoT monitoring platform is that we can quite often preemptively identify any issues with input water quality, input water supply, power outages, things like that. So we can schedule maintenance preemptively by watching the systems as they are performing. So before it's had a major impact on output, we will know that quite often we can identify a very specific component that is broken, and we can actually send a technician out with a very clear brief on how to replace that single component. So that's why we prefer to use, to the extent possible for something like this, off-the-shelf core components, because they can very easily be maintained by third-party technicians on site.
Thanks, James. We have 40 seconds left. Vanessa, would you like to jump in with a question, a very quick one?
No.
Alexandra, do you have an extra question? 30 seconds left.
I'd like to have an idea of the total cost of this machine. Is it possible to have an idea of it?
Yeah, we can't, we don't have enough detail actually at this stage. It will depend on location, it will depend on primary water treatment capacity, but it will be, I can say confidently, it will be as competitive as any other offering out there because we're using existing componentry. To develop something entirely from scratch would be a far, far more costly and time-consuming process, which is why, again, we think this is the most efficient way.
Thank you very much. Thank you very much, James. We need to stop here for this switch. Thank you very much for your very interesting presentation and taking the time today. I'm going to just stop your screen sharing. Perfect. So now I'm going to call Morandini Mafumo, co-founder of Mobi-Water and Filters based in Johannesburg, South Africa. Welcome, Morandini. How are you?
I am very well, thanks. How are you?
I'm fine. Given the fact that I'm also based in South Africa, and I know that we are in load shedding level 4, I assume everything is fine on your end and we are not going to get cut. There is not load shedding at like 3:30 on your side.
No. I'm being load shedded at 8 p.m. tonight, so
okay.
Yeah, okay. Touch wood.
All right. Okay, great. So same rules as for James. You can go to your first slide, and as soon as you're ready, I'm starting the timer for 7 minutes.
All right. Do you see my slides right now?
Yeah. So I see your slide. It's clear, and the connection is clear on your end, so we are all good to go.
Perfect. Hi everyone. My name is Morandini Mafumo. I am a water scientist. So I spent the last 10 years working for municipalities. I used to work for City of Cape Town as a water scientist, as well as Johannesburg Water. As a water scientist, I worked partly as a water engineer as well. So our job in the city was to research and development for water provision for the cities, as well as increasing access to safe drinking water for communities that do not have, primarily speaking, it would be informal settlements, as well as the outlying regions. So over the last 10 years, I worked for the municipalities in total, and I've been running Kusini Water for the last 3 years. At Kusini Water, we make use of locally sourced macadamia nut shells to make water purification system, as well as nanofibers. We get the macadamia nut shells from local farmers, which is of waste material. We make that into a carbon filter, as well as nanofiber filters. As you would know, especially with this challenge, one of the biggest challenges that we're facing, especially within the African continent, is the ability for water security, not just water security for low-income communities, not just water security for informal settlement, but also water security for businesses. One of the most key business risks that a lot of businesses are facing is the ability to predict water quantity, the ability to predict availability of water, as well as the ability to have some sort of control over the quality of the water that those companies are using. So we partner with local companies. We work a lot with multinational companies to ensure that they've got, one, water security, and number two, they've got some sort of social impact within the communities that they operate in. So we, for example, Red Bull had a challenge in their office in Waterfront where they'd like to obviously ensure that there's water, ongoing water within their building, as well as have impact on communities. So we're putting in a desalination water treatment facility for them. So our solution is our water purification system is basically two stages. So one is the purification system itself. The purification system is built from two components primarily. It will be the nanofibers. So the nanofibers can remove anything from bacteria, viruses, up to 99.99% of all bacteria, viruses are removed from that. The second part of that is obviously the carbon fiber, the activated carbon purification system that we get it from locally sourced macadamia nut shell. All of that, then we get to put it in a box. It's an off-grid box, which is solar powered, and it comes standard with an IoT platform connected to it. That IoT platform would have about 5 sensors. Those 5 sensors are able to give us data of the water flow at each given time. We're at the moment testing at each given time some quality parameters, including TDS, turbidity, and some other water quality parameters. We're growing that part of the business as well. And we're able to obviously monitor the energy usage of the system. The system is off-grid because of the fact that our systems, we want to be able to lift them from our manufacturing space to any community, be able to treat water from any water source without needing any grid energy, especially considering where a lot of the communities that work in, where energy. It's not just water that's at risk, but also energy reliability is also a challenge. So our product is a patented product. We've got a patent, a design patent, as well as a functional patent pending at the moment, which is a device that allows for water purification, uses nanofiber material, as well as activated carbon made from locally sourced macadamia nut shells. We've got about 2 patents and 1 patent pending at the moment. And each of these devices does about 250 liters per hour. And in the box would, generally speaking, have between 2 and 4 of these filters, which gives us between 500 liters per hour to about 1,000 liters per hour, just depending on the operations. This is one of our boxes on location. Our boxes would come standard either, depending on the operations of the box itself, it comes standard with between 2 and 4 filters. It comes standard with an IoT, all 5 sensors connected to our IoT platform. It also comes standard with the solar power, UPS system, as well as battery system. And it's basically a plug and play. It's basically a plug and play system for any water source. We sometimes would pair that with a UV sterilization. Sometimes we can add a nanofiber membrane. Just depends on the water source, as James has mentioned, that the water source can differ from area to area. As I said, this is basically just the source material for our purification system. And this is basically part of our platform. We, at the moment, I'll just show you a little bit about our traction, and then I'll go back to the platform. At the moment, we treat roughly about 3 million liters of water every month at the moment in about, give or take 30 sites, about 29 sites, and 1 retail site. In those sites, it's schools, it's clinics, it's buildings, and we're able to monitor and remotely control the systems. We've got helping 20 sites, 5 sites in the KwaZulu-Natal region, as well as 4 sites in the Western Cape region. This is a little bit about where we come from. We launched our first product in 2017. I left my job at Joburg Water in 2016 with our first product launched 2017. This year, we're going to be rolling out to roughly about 50 sites, and next year we should be in about 100 sites, and also be able to have a much lower cost water purification device. So our solution for this challenge lies on 2 things. So one is the off-grid box. So we want to be able to, at each airport, especially we'll start with proof of concept, even in the Johannesburg airport, in the Cape Town airport, put up a one of our off-grid boxes with 4 membranes. The off-grid box comes standard with UPS as well as onboard tanks. To the tank, the onboard tanks can hold anything roughly from about 100 liters to about 200 liters at each given time. So we easily just transport that, put it in the airport, we're able to purify that, and the water can then be pumped into the holding vessel that can be put into the plane. And as I said, we can take any water source from rainwater to borehole water. This is basically just the solution in terms of just what I explained. And in terms of our how we charge for the system, basically we work in 4 different ways. So it can be an outright sale. One of the units starts at about $10,000 US, and also we've got subscription where some of our clients just pay a monthly subscription for the box that comes standard with full maintenance.
I'm sorry, Morandina, I need to stop you here because the 7 minutes are expired, and I'm sorry, I don't like to argue, but we just need to keep it fair for everyone. So I will stop you here. I'm resetting the timer. Thank you very much for your presentation. Again, another very interesting idea. Vanessa, would you like to start the Q&A session? I'm starting the timer with a question.
Yes. Could you tell me the frequency of change of a filter or of maintenance?
Yes. So roughly, we've been in all of the sites. Average is about 8 months for the first filtration system to be removed. So it's about 8 to 12 months of the first sort of maintenance of the first filter, and the overall of the membrane is about 5 years or so. But maintenance, we're looking at it from a 8 to 12 months. Every single day, we are able to monitor the pressure. We're able to see just how much water is being used from each different point. And from what we've seen over the last couple of years is most of the devices at about, because of the fact that our system automatically does backwashing, we're able to push them to about 8 months before we have to do minor maintenance.
And what is the cost, the approximative cost of a filter?
Yes, so the box, the complete system altogether is about $10,000 US. The filtration system, each individual filtration system, it starts at about $1,000. It's about $1,000 US for the set of 4. The maintenance of it, which is the removal of the inside cartridge, is about 10% of that. So we're looking at about $1,000 maintenance cost per box every couple of months. We'll look at it from 6 to 12 months, just depending on the source water.
Okay, thank you.
Thanks, Morandi. Alexandra, would you like to jump in with a question?
Yes, so just to be sure to understand, so the water box you offer would be at the airport, and then there would be a truck which be filled in by the water box. How do you imagine that on the airport?
Yeah, so how I imagine it is at close as possible to the filling stations would have the box with some amount of water stored in already, and then I'd like to think the best way of doing it would be some sort of a trailer system where the water gets pumped into the big holding tank, about the 500 liters that's needed, and then transported on board afterwards. So I think if the system is put as close as possible to where the loading happens, we can sort of minimize the time that it would take to take from holding the trailer on board. But the box itself comes standard fitted with a holding tank as well, which we can sort of custom size it to the needs from each airport.
Okay.
Yes, thanks, Morandi. Alexandra, do you need more clarification on this point, or do you have another question? We have three and a half minutes left.
It's okay for me on this point. I just wanted to know if it's possible to check if the filter is still effective.
Yeah. So one of the ways that we look at it is pressure drop. So generally speaking, from the UF pressure drop, we know how much the pressure drop would be. So sometimes it's between 1.5 to about 2.5 bar pressure drop. If the pressure drop becomes too high, we know that one of the filters is not efficient. At each given point, we've got about 4 or so membranes in each box. At each given point between all of those membranes, there is a pressure monitor. So if the pressure drop becomes too high, we know that one of the filters is inefficient. We have a pressure drop alert, which shows us that one of the pressure points is the pressure drop is too high, meaning that the filter is taking too long to filter the water. So we are able to monitor the pressure drop, and we're able to then see that, okay, one of the filters is now not reaching its life. Because of the fact that, I mean, at each given time, we collect close to 95,000 data points, we can predict that when each filter will need to be replaced.
Mm-hmm. Okay.
Thanks, Morandi. Vanessa, if you don't have more question or clarification, maybe Vanessa, you have a question. We have a bit more than 2 minutes left.
No, it's okay for me.
Okay on your side, Alexandra?
Okay as well. So we have the cost. We have yes, it's clear. So
okay.
No, thank you very much.
Thank you very much.
If we would have a question afterwards, is it possible to let them know our questions? How does it work?
Yes. So I'm just stopping the timer now. So basically, how it's going to work is we will have a debrief after that. But for now, we need to stick it to the content that would have been delivered during this session to keep it fair for everyone, obviously. Yeah.
Okay. Yeah.
Great. Thank you very much, Morandi. Thank you. I'm going to now call on stage, please, Kelvin Gachiru, founder of Mobi-Water, based in Kenya, so spirit of load shedding, some extent. Hey, yeah. Kelvin, how are you? Can you hear me nicely?
Yeah, I can hear you. Can you hear me?
Yeah, I can hear you. Well, so Kelvin, you know the rule of the game. I will let you share your screen. Perfect. So just full screen. Let me reset the timer on my end. Kelvin, it is whenever you're ready.
Okay, sure. Hello, everyone. My name is Kelvin Gasheru, founder and CEO of Mobi-Water Solutions. And our key product, Mobi-Water, is a real-time water monitoring solution that's currently being used by factories, industries, and businesses to ideally monitor and manage their water. So what we do is we develop solutions that help collect data, analyze data, and help institutions make informed decisions on how they're managing and using their water. So I was really intrigued about this challenge because it's one of the things that we've been really looking to integrate. One of our key or core focus of Mobi-Water is to develop solutions, especially technological solutions that will allow the water value chain to become much more smarter and much more efficient. And this is ideally resonates with the whole challenge. Ideally being able to ensure that African airports have good quality water that can actually be meet the guaranteed standards that are set by the KLM Group and be used as refilling water within these different flights. So our solution ideally focused on 3 parameters. One is looking to integrate a smart water treatment unit. I think the 2 presentations above really focused on this. Second was looking at how do we remotely monitor water quality. So looking at the physical parameters and how this ideally would help us to be able to, one, monitor the actual treatment. How is it happening? How do, if at any one point in time, we need to do any sort of maintenance. And then also looking at recontamination. So if the water is going to be picked from a different facility and transported to the truck, how do we track and prevent recontamination at this particular point? And then being able to have all this data uploaded into one specific platform, and then allowing the client, which is basically Air France, to be able to track this using the operations team remotely, but also have the on-site teams in the different airports being able to get this data. Because at the end of the day, we still need them to be able to do all the maintenance, to be able to ensure all the checks are okay. So we're looking at how to create a cross-platform that will allow an online dashboard for remote monitoring and accessing. And then because most of the African airports, you may probably find issues with internet access to the internet, looking at something as basic as an SMS notification that can allow on-site operators to be able to track this. So within the 3 parameters that we're looking at, for the treatment, we're actually looking at how the machine is working, how effective is it, looking at pressure levels, physical parameters, how do we ensure that the machine is running at optimum conditions. Second is on the tank storage. So most facilities will more or less tend to have an on-site storage tank, which is primarily what we do at Mobi-Water. So being able to track how much water is in the tank, what's the quality of water in the tank, what's the consumption or ideally flow rate that is being produced by the water treatment unit, so that at any one point in time, we're able to tell the quality of water inside that storage tank and the amount of water that has been produced and when it was produced, so that we don't have water staying on site on one tank for a very long period of time. And then thirdly, looking at the refill track. So ideally prefitting that with water quality sensors, looking at the basic physical parameters such as pH, conductivity, salinity, dissolved oxygen, which in a way can be used to track microbial growth within the water, reduce or increase oxygen levels. And then also looking at the volume and the level that's being refilled onto the tanker. So ideally the point of refill will enable us to be able to track the water that's being filled onto the plane. So a little bit about our company. We started Mobi-Water in 2016, ideally working with different organizations to track their projects in different locations in Kenya. We have about 230 sites scattered across Kenya, Sierra Leone, and Madagascar. So the reason why we opted to work with those 2 countries is we were looking at piloting our systems, one in West Africa and Sierra Leone, and also looking at how we can deploy our systems in Madagascar. And primarily, we develop the whole hardware solution and the software solution, so it's fully proprietary. Depending on the client needs or the on-site needs, we're able to customize the solution to fit into the specific installation site, and also offer a maintenance for that. And then we also develop the full end-to-end software to do this. So both the device management platform and also the monitoring and alarm system that allows the maintenance teams to receive notifications. We are largely a team of engineers. So we have water resource engineer, that's my professional background, but also work a lot with electrical engineers and software designers. So primarily we're a team of about 15, but this is the core team. And then we have installation technicians that help us to implement different projects. Previously, we've been part of the Airbus Base Lab Africa for Future Challenge. So that was in 2019. And we've also worked with Aqua for All, which is a Dutch-based NGO. So we largely help them track their projects here in Kenya, but they can track them with their head office in the Netherlands. We also work with the Royal Academy of Engineering, largely through research and development, and also deploying solutions to the different countries such as Sierra Leone. And then MEST largely provide us with entrepreneurial support and growth. So what we're ideally looking at is a multi-parameter water quality monitoring solution that can ideally be deployed on the tank as well as on the truck. So we're looking at one similar system that is being used in both locations that can be able to track water quality, and also looking at ensuring there's no recontamination. So the system on the tank will tell us if the water treatment is not working well. The system on the truck tells us if there's recontamination, either when taking water from the tank onto the truck. And then we've ideally been looking at how to structure this in terms of the R&D cost. Looking at about 150K euros to be able to develop this platform and ideally customize it for the different airports. Because we expect different water challenges or different issues within the different airports. But if we have the key points that we'll be looking at in the water quality, we can be able to get off-the-shelf sensors that can be able to ideally help us target those particular solutions. Once again, my name is Kevin Gasheru. I'm founder and CEO of Mobi Water Solutions. Thank you.
Thank you. Thank you very much, Kelvin. Thanks. Thanks for this presentation. Vanessa, do you want to, so let me just reset the timer. Would you like to start with a question to Kelvin?
Yes. I would like to have more information concerning the key parameters which will be tracked. Do you imagine testing other parameters like critical parameters like coliforms or E. coli?
I think what we can do around that ideally is have a scheduled test for that, because most of the time that might have to be an on-site, an off-site test for that. Although there are some cases where you have carry-on motor testing kits, but I would advise that if you want to do the full physical, chemical, and bacteriological test, you can schedule that either as a monthly test for that. But with some of the sensors, for example, as I said, if you're looking at dissolved oxygen, that would ideally give you an indication of conditions that would ideally allow microbial growth. So if you have lower levels of dissolved oxygen, it means that you have microbes within the water that is consuming the oxygen. So that would allow you to immediately know that you have microbial growth within the water. And also looking at things such as changes in temperature. So if we have the specific conditions or the specific key points that we would be looking, because then again, we don't want to have a system that is completely 30+ sensors, because that would be very difficult to deploy and also to maintain. So if we can come up with the key parameters, then we can be able to schedule those full end-to-end water quality tests. But physical sensors will actually help you to predict that also.
Okay.
Thanks, Kevin. Alexandra, a question?
Yes, I have a question about the water treatment, because for me, it looks like that it's more a solution to monitor water than a solution to provide clean water. So maybe I not understand the system globally, but yeah, can you let us know how you treat the water to ensure that we have clean water?
Okay, so the reason why we focus primarily on the monitoring is because if you look at the market right now, you can actually be able to source for smart water treatment solutions. I think the two pitches ahead of me already have that. And I think even locally here in Kenya, you can find off-the-shelf smart solutions. All you need to do is know the specific parameters of your water, so whether it's high in fluoride, whether it's high in turbidity, whether it's concentrated salts, and then you design a water treatment unit around that. But for me, because the key thing for me was looking at, since we already have lots of off-the-shelf water treatment units, whether it's reverse osmosis, ultrafiltration, microfiltration, that you can purchase off the shelf. It's already smart enabled, so you can get your data. What I was looking at is being able to design a solution around, once the water is treated, how do we ensure that the quality remains the same, even as you actually loading it into the plane. So that was our thinking behind why to focus largely on the monitoring aspect, the quality monitoring aspect, maintaining the quality, as opposed to the treatment, which ideally units, water treatment units are largely available across different countries.
Thanks, Kelvin. We have 2 minutes left. Vanessa, do you have a question for Kelvin?
Maybe just a precision with Alexandra's question.
Okay.
Who will do the treatment of the water if you do more monitoring than treatment?
Mm-hmm. So what we'll do is ideally have this as a packaged solution. So for example, one of our key things that we actually do as Mobi-Water is to provide bulk water delivery services to our clients. And what we do is we treat the water on site using RO. We put the water in our trucks and then we deliver that to our clients. And that's why I said this really resonates to what we're actually doing. So for us, it's very, very difficult to have an innovation around the water treatment, because that's largely decided by the quality of water that you get. So on some sites, we have just basic microfiltration with a filter and then maybe a chlorine doser. In other sites where we have water with very high fluoride levels, then we opt to use reverse osmosis. But for us, because with our trucking business, our biggest challenge has always been, we treat the water on site, but by the time we're delivering the water to our clients, the quality actually changes based off of different recontamination levels. So it might be windy, it might be dusty. So that sort of thing is why we opted to focus on how do we ensure the quality first.
Thanks, Kelvin. We have 45 seconds left. Alexandra, would you like to jump in with the last question?
Yes, so for example, if we test the water and it's not clean water the day of the filling, is it possible to treat the water the same day to be able to have clean water for the aircraft?
Yes, so depending on the demand, of which here is 500 liters per 500 liters per flight. Ideally, what you can do is whenever you order a water treatment unit, one of the key parameters that they look at is, one, the quality of water that the source water that you're getting, and then two, they look at the demand that you have. So based off of the demand, 500 liters isn't a very, very huge demand, especially per flight. But you mentioned that you have almost 120 flights. So if what you can do is have a unit that can produce, let's say, around 2,000 liters of water per hour, and you can be able to have that incorporated with the monitoring system. So the key thing with treatment units is usually the quality of source of water and your actual demand or your output that you actually need.
Kelvin, yeah, thank you very much. We will have to stick to this last sentence, which at the end of our time. Thank you very much for your pitch and your solution as well. Well, we are actually arriving at the end of the event. So firstly, thank you very much to you, James, to you, Kelvin, and to you, Marendi, for taking the time today. But also taking the time to prepare those decks, because I know how much time it takes to put ideas into a deck. So thank you very much for all of this time. Thanks also to Air France KLM, of course. Without them, this event and this challenge will not be possible. So when it comes to the next step now, so that was basically just a pitch event to see some solutions for this problem. The next step now is, so on the Air France KLM side, they are going to have a debrief, and then we have our summit in Cape Town. So we just confirmed actually 2 days ago that we'll have our summit in Cape Town at the end of November, where we will have 3 startups that would be pitching their solutions for this Air France KLM challenge. So most likely we will see some faces that we are currently seeing today. The event would be in Cape Town. The idea is to fly the startups to Cape Town. It doesn't matter where they are. So from Kenya, from Johannesburg, for you, James, it's different. You're already in Cape Town. So that's basically the 2 next steps. Debrief on the Air France KLM side, and then we'll have 3 finalists pitching at the AfricArena summit at the end of November. Obviously, we will adhere to the strict regulations when it comes to physical distancing, etc. So that's it for today. Again, thank you very much to everyone. We will obviously be in touch by email. You will also see a sum up of this pitch event as well as other details in our newsletters and social media platform. Thanks again to everyone. Have a nice afternoon. Bye-bye.
Okay. Thank you for the opportunity.
Thank you very much.
Bye.
Bye.
Thanks, everyone.